Hello, and welcome to a special edition of Ethanol Producer Magazine podcast. I am your host, Katie Schroeder, contributions editor with EPM. Today we are hearing a panel preview for this year's upcoming fuel ethanol workshop. This year, our track 2 is covering productions and plant operations, specifically exploring mechanical processes and plant control. And today I have with me Roy Viteri, business development manager with RCM Engineering-Thermal Kinetics. He's going to give us a preview of his presentation, Revamping Your Distillation, Dehydration, and Evaporation System. He'll be giving the full presentation at the panel, Examining Strategic Advances in Next Era Distillation, Drying, and Evaporation on Tuesday, June 10th at 3 p.m. in Omaha. So welcome to the show, Roy. It's great to have you.
Thank you, Katie. Thanks for having me on. This is an exciting little preview for the presentation. We'll have some video, some photos, and hopefully some lively engagement.
Great. Yes, absolutely. I'm looking forward to that. So just to get us started, could you introduce yourself to the audience and just kind of talk about what initially interested you in presenting on this topic?
Great. So, yes, my name's Roy Viteri, and I am a chemical engineer. So the title business development manager kind of throws some people off. But so my background is in chemical engineering. I've been doing it for almost 4 decades, and I spent quite a bit of time in the Texas Gulf Coast, traveling around the world, troubleshooting some of the world's largest refineries, and moved over into this space at RCM Thermal Kinetics and figured, hey, I think there's an opening in the industry where they need some help on how to push more products through through customers' equipment. And so our next program has been quite successful as we help expand customers' production capabilities.
Awesome. So what are some common bottlenecks in distillation, dehydration, and evaporation systems that ethanol producers face today, and how does the next program specifically address them?
Well, some of the most common bottlenecks we see in DD&E, which is short for distillation, dehydration, and evaporation, are just your typical hydraulic limitations, especially in distillation columns, often caused by inefficient internals. We're it's a pretty mature industry now, the fuel ethanol industry is, and so a lot of the units maybe started off as some 40s or some 50 million gallon a year units, and now we're being tasked with getting as much as we can out of the units so that customers don't have to spend any more money on new pieces of equipment. So modifying what they've got without having to replace a bunch of stuff is the way to go, and so we've been quite successful doing that. Another kind of bottleneck is inadequate heat recovery or integration. So as plants get pushed to do more, they need more. And heat transfer surface area is one of the areas. Capacity limitations in evaporation systems are also often a bottleneck due to fouling of thin stillage, syrup type material. So we try to find ways of overcoming that with circulation or controlling LMTDs in the evaporators. And poor dehydration performance in the molecular sieves often are caused because of suboptimal regeneration cycles. So we help customers fine-tune those mole sieves.
Great. So I noticed in your abstract, you mentioned that thermal kinetics emphasizes the integration of complex fluid flow hydraulics and process fundamentals in the next program. Could you explain how this deep understanding translates into practical improvements in plant performance?
Absolutely. Understanding fluid flow hydraulics is essential in all systems, but in the fuel ethanol systems, it's like many others where equipment often operates near limitations like flooding of the towers or inadequate residence times. Many legacy plants were designed conservatively, so when they were designed 20 plus odd years ago, they had plenty of room to grow, but customers have been smart and pushed their systems. Now they're at the point where they've maybe pushed all they could out of the original design, and now they're looking for some minor modifications, let's call it, in some of the equipment. With the next program, we apply advanced hydraulic modeling, including pressure drop analysis, tray and packing capacity curves, flow distribution analysis. And so we optimize how liquid and vapor should be moving through each piece of equipment, through piping. And so we take into account all of those parameters in helping select what modifications really need to be done, not what would be nice to be done. So this level of precision engineering translates directly to higher production rates, lower energy usage, and just more stable operations, even at higher loads.
Yeah, thank you for the breakdown. The next question I have here mentions that energy efficiency is a key focus, as I'm sure you know, for modern ethanol production.
Oh, yeah.
So what innovative strategies or technologies within the next program have demonstrated the most impact in reducing energy consumption?
Well, energy consumption is often the largest operating cost in ethanol production. And so our goal is to attack that on multiple fronts. So some of the strategies we use are just heat integration and reuse. We often install additional heat exchanger surface area onto existing ones to recover heat from, let's say, mash to beer feed. On the multi-effect evaporation systems, we improve temperature gradients and steam distribution across effects. So we try to reduce total steam usage. And we just look at implementing better control strategies in the control tuning. As we modify operating parameters in the equipment, we often find operators find it difficult to kind of switch from, hey, the way we used to do things, to, oh, these are some of the changes we needed to do moving forward. And so we help operators understand what modifications are being made and what they should expect to see on the control board.
Yeah, that makes sense. So how does the next approach differ from conventional plant revamp strategies, and what kind of production gains have clients typically experienced after implementing some of these different changes?
So conventional revamps often focus on isolated kind of upgrades, swapping a pump, maybe a bigger impeller, adding a sieve bed, or debottlenecking a single column. Our next approach is a total systems, holistic approach to reviewing the entire operation. And so we assess the entire DD&E unit as an interconnected whole. As I often say, the knee bone's connected to the elbow bone as a joke, because, one tweak here is going to affect you way down there. And if you haven't thought about how that's going to happen, then you can kind of get caught out there on a limb. And so some of the key differences include a data-driven pressure survey and temperature survey that we do to set or form the baseline for the current operation of the plant. We also custom engineer our solutions rather than try to pull off the shelf type designs for equipment. And we focus on both capacity and efficiency, not just one or the other. So when we're revamping a tower, we're looking at, hey, what other modifications can we be making in, let's say, the rectifier tower? If we need to try to improve proofs on the distillate, can we get some different sort of packing in there to help us get there? That helps, on steam usage. And then minimal disruption. So typical turnaround windows, let's say in different industries, they're talking about maybe a few weeks to a month, where in the fuel ethanol industry, we're often talking about less than a week, 4 days, 5 days type shutdown periods.
Yeah, great. Thanks for that info. So looking ahead, how do you see the role of the next program evolving as ethanol facilities adapt to stricter sustainability targets and shifting market demands globally?
So as global markets demand more low carbon intensity ethanol and fuels, and as policies evolve, like the GREET model or the LCFS credits, facilities need to do more with less, right? Less energy, less water, fewer emissions. And so our next program is well positioned to meet the demands, because directly reduces energy usage and emissions per gallon of ethanol on a very detailed and holistic approach to the revamps. It also supports the integration of renewable steam sources or waste heat recovery. We can incorporate MVR technology into our designs, and it enables producers to maintain high capacity without expanding their kind of carbon footprint. So in the future, we see Next evolving into including carbon tracking and AI-driven performance monitoring that align with digital plant strategies. As sustainability becomes central to companies' competitiveness, I think our next program will be an enabler of both operational excellence and environmental compliance.
Awesome. Great. Thanks so much for that response, Roy. I'm looking forward to seeing you at the FEW. Just out of curiosity, how long have you been coming to the FEW over the years?
So I think this will be my fourth year in a row, but I've been to
Awesome.
the FEW back when it was more fledgling. So it had to be over a decade before. So
Wow, that's
when I had,
awesome.
yeah.
That's great. Well, we're excited to have you again and looking forward to hearing the full presentation. If the audience would like to catch Roy's presentation in full, it will be on the Examining Strategic Advances in Next Era Distillation, Drying, and Evaporation panel at 3 p.m. on Tuesday, June 10th. You can go to few.bbiconferences.com to see the full agenda, register, and learn more. Hope to see you all there, and thank you so much for giving us a little sneak peek, Roy. Really appreciate it.
Thank you, Katie. Look forward to seeing you and everybody else at the FEW.
Great. Thank you.